Hello, everyone, and thanks for joining our webinar here today. We're excited to get this rolling. It is 12:30, so we're going to go ahead and get this started. The meeting will be recorded, so if you want to go back and check anything out, feel free to. Go ahead and, if you want, drop in the chat where you're tuning in from today. We'd really appreciate it. And we'll get rolling here in about one more minute. We will be handing it over to Rob and Nimrod to kind of be going through our navigating regulations and maximizing UAS potential. If you have any questions, feel free to drop them in the chat on the side. My name's Adam. I'll kind of be moderating here, taking down questions and making sure that Nimrod and Rob have some time to answer. We will have plenty of time at the end for Q&A. We only anticipate the presentation to go for about 30-40 minutes, giving us about 20 or so plus minutes for Q&A. So with that, I'm going to go ahead and turn it over to Rob to give us a quick intro, and then after Rob's done, I'll pass off to Nimrod.
Yeah, good afternoon, everybody, or morning, wherever you happen to be. My name is Rob Knockenhauer. I'm the Director of Regulatory Affairs here at Census Technologies, and looking forward to kind of talking to you all about what we do here and how we work together with our good friends at Elsight.
Thank you, Rob. I'm Nimrod Linder. I'm the VP Sales at Elsight, based in Israel. Elsight is an enabler, and for me and the team is not only to find the right partners who are going through the regulator process, but also enable it and help push the industry forward.
All right, let me get this presentation rolling here, and Rob, I'll let you take it away.
All right, thanks, Adam. All right, so today we're just going to go through kind of a history of commercial drone regulations. And as many of you probably know, Part 107 is the rules that were developed by the FAA and published in 2016 to allow the use of commercial drones drones for commercial operations. And when Part 107 went live, they released these rules that were subject to relief via a waiver. And so the 10 articles that are subject to that relief are these numbers here, which range from everything from BVLOS, which is the big one, 10731, which is what we're going to really get into, to 39 and 145 are for people and moving vehicles. 51 is kind of related to weather considerations, like lower than allowable visibility, like if you were to operate with lower cloud ceilings in more IFR types of conditions for drones, or if you wanted to operate above 400 feet or in excess of the 100-mile-an-hour speed restriction that is captured in Part 107. 29 is now actually covered primarily under a rule that was the night waiver. So when the rule went live in 2021, basically changing it so that all you needed to do was effectively show that you understand how to do night operations via the certification test for remote pilots, that requirement for actually being able to do a standalone waiver for night operations went away, thank goodness. And the others are regarding to if you're doing operations from a moving vehicle. 37 is for giving right of way to an aircraft. Fun fact, I don't believe there have been any waivers issued where a drone is given right of way over a crewed aircraft. So those are the waivers are subject to relief from regulation. So what we're going to talk about today is some of the common waivers that have been published. Which if you track the waivers as much as I do, you would kind of see some trends. One of the ones that's a trend that isn't really actually listed here is there's been an uptick in the numbers of waivers granted for operations over people and moving vehicles, and those were basically leveraging the ASTM parachute standard primarily. The rationale for why there's been an uptick is because of the waivers that were allowed, or actually in 2021 when the night rule went out, there also became an operations over people rule that went out, or where FAA specified categories for which an aircraft could be allowed to do operations over people. There was only one aircraft for the longest time that had been compliant with that, which was the EB aircraft, which is good if you can use it in case to do those types of operations. So, but anyhow, back to this. The tactical BVLOS, those are the waivers that are granted for people that are running operations like inspecting infrastructure like bridges, that sort of thing, where basically you're operating the aircraft just outside of the line of sight of the pilot, but very close to the pilot. So typically that is using the infrastructure itself as kind of a masking to assure that it maintains well clear from any air risk that might be involved in those operations. Kind of related to that is the shielded waiver, which is an operation where you can operate longer distances away. And this is an example of that. That census has been granted about a year ago. Actually, it was last fall. We were granted this operational approval to do operations for up to 40 miles point to point, but primarily the operations we do are out and backs, up to a maximum distance of about 20 miles. And the premise here is that you can do this operation without having to leverage the use of visual observers to manage your air risk. You may still have to use visual observers to manage your ground risk, kind of depending on where you're actually conducting the operations. The advantage here is that you're able to fly up to 100 feet above the infrastructure. The disadvantage, of course, is if you needed to capture larger swaths of area, then you may not necessarily be able to capture all that data in a single operation. All right, back to this here. So there are DFR programs that are run, not necessarily, most of them are actually not run under Part 107, but these are the rules that they would be granted if they were operating under 107, which is BVLOS. You would have, in some cases, visual observers associated with those operations, in some cases not, depending on what they have in places for understanding of their airspace. Some of the DFR programs are leveraging ground-based sensors for airspace awareness. And then they'll also seek approvals where they have their aircraft equipped with a parachute for becoming compliant with the ops over people request. In other cases, the public safety folks are able to actually run operations in a DFR program under Part 91. And in Part 91, they're able to basically establish a level of safety requirements, or basically public safety allows them to kind of not necessarily have to comply fully with the need for parachutes in that context. That's a whole nother topic. So, and then finally you have next is a geo-constraint waiver. So this would basically be a waiver that is fixed to a specific location. Most of the waivers that we work on with is the next one, the nationwide BVLOS, which is a performance-based approval. A lot of the clients that we work with seek a performance-based approval here, which is this nationwide. The premise here is that we set criteria that we put in front of the FAA on behalf of ourselves and our clients that basically, define a set of parameters that they need to do to look at when they set up a new location for doing a BVLOS operation. It's a way that basically allows any operator to have a greater level of flexibility, because they have an approval already in place from the FAA that allows them to do operations. However, there is a responsibility that comes with that, where the operator that is granted this type of waiver has to maintain records showing that any area that they're conducting BVLOS operations at, it fits the criteria that is outlined in their approved waiver. So that is really probably one of the things that is the most complicated piece about doing BVLOS operations in a performance-based context to this day, is that, for any operation that you run where you're choosing a new location, the ratio of preparation to operation time is about 8 or 10 to 1. So, I mean, basically for 1 hour of flight time, you're spending, 8 to 10 hours of planning, site evaluation, verifying that it is good. So if you're doing an operation where you're able to go back to the same area that you've already previously flown, then certainly your second time out would be a little lower, but certainly those initial outings are pretty involved. All right. Right. So the other one is we're talking about extended line of sight waivers. So those are waivers that are still very common. So they've been kind of mischaracterized as BVLOS. Basically, it's a waiver that gets approved where you can fly beyond visual line of sight of the pilot, but you're using visual observers to maintain line of sight of the with visual connection with the aircraft. A number of the waivers that we're working on with these days, we don't necessarily the language that we've put forward doesn't have us actually maintain line of sight of the aircraft, but more just an awareness of the airspace when we have operations that are leveraging visual observers. Back to this other one, which is the high altitude waiver. So those can be standalones, and many times they have been a standalone where basically somebody is looking to operate above 400 feet for whatever purpose, for some operation, and you can get a standalone approval for that. We've actually coupled it in a few cases where we're doing BVLOS as well as operating above 400 feet. So the ones that we've worked on have all been right around 1,000 feet has kind of been the target that we've worked with. And beyond that, there are other organizations looking to go higher. The challenge with going higher is that now you're actually more in general airspace. And so you get into a different group of people at the FAA that are evaluating any approval or any request that is for operations above 400 feet. So it's the team at Flight Standards that evaluates most Part 107 waiver requests. But when you go above 400 feet, then you get into the having to work with air traffic organization. So ATO does the evaluations of those requests, and they typically end up taking a little bit longer because of that added layer of involvement from the FAA. And then this last piece here is the remote BVLOS waiver. So probably many folks have seen enough news at this point about a number of organizations that have been leveraging drone box solutions. So you have these docks, whether it's something that's made by companies like Skydio or Percepto or American Robotics, and then obviously DJI has finally gotten into that game as well. Those are operations where you can have a fixed small aircraft that is able to kind of monitor a relatively localized asset. So, all right, moving on. So the waiver process, so how you actually go about applying for a relief from one of the rules under Part 107. First thing you need to do is you need to identify what it is exactly that you're looking to accomplish. So you put this as your concept of operations, and you want to basically put in as many details into this concept of operations as possible to make sure that whoever is reviewing your request understands what it is you're trying to accomplish. Once you've outlined what your operation is through your ConOp, you go through and you identify all of the risk that you have that are associated with that operation. It could be air risk. I mean, this is typically what it comes down to. It's air risk and ground risk. And then in addition to that, there's another element, which would be your equipment reliability risk. And then once you identify all of the risks that are in your operation, then you identify, what contingency plans you have in place or your mitigations that you'll have in place to assure that you are managing those risks in a way that is acceptable to the FAA. Once you have your risk and mitigations outlined, you want to describe, all the different systems and how that they'll work, within the context of those risk and mitigations, and, particularly how the aircraft works, how your ground control station works, how your communications link between your aircraft and your ground control station works in a way that is going to be robust and reliable. Once you've done all of these things, there's one thing that I realized that I didn't describe here is part of the process is to answer there's a series of questions that the FAA has generated for everybody to use to ease the FAA's evaluation process of a waiver request. And those are the waiver safety explanation guideline questions. And so, right, and so we're getting into the common mistakes, and you know, once you get in there, so part of the package, it probably should have been included in the previous slide, is that, you know, those questions, when we prepare a waiver for our clients or for ourselves, we make sure that we have all those questions explicitly answered in addition to the concept of operation. So if your waiver is put together, you know, in a way that the flow that I personally have kind of gravitated to is like, I'll go through and I'll come up with this concept of operation, the full description of how it works, really define that pretty clearly. And a lot of that, how it works, and then the risk and mitigations that you're identifying all spell into the waiver safety explanation guideline questions. But the questions are like discrete questions looking for just very direct answers. And so even though those direct answers are probably in the concept of operations and the risk and mitigations, I find it, you know, useful to reiterate those points to answer those discrete questions that are asked by the FAA in the waiver safety explanation guideline questions. And yeah, so there's if you type in that term, waiver safety explanation guideline, it'll take you to the FAA's website where you can find that document. All right. Right. And so once you have everything answered, you put it into the drone zone. And I guess now we can go to the next slide there, talking about the common pitfalls there. Again, so the big pitfalls there is that you don't give enough information about your operation. You have you don't describe your concept in a way that is clear. You make some assumptions where, you know, again, it all comes down to like, you know, the people that are reading it they're not going to know like how your specific controller works. So you need to spell out, you know, the steps that you're going through in the powering up of the controller and the information that you're seeing on the screen, and communicating that in the document as you spell out that concept of operations. So another piece is when you identify your risk, if there are things that you're just kind of, you know, overlooking. In the case of the performance-based requests that we put in and that we have had, you know, success in getting approved, you know, we identify the possibility that we're going to fly over roadways. If you were to put together a performance-based request and not really, you know, fully describe the types of areas that you're going to be operating in, or gloss over things like roads or those types of things that, you know, will provide like an elevated ground risk that you just simply don't address. Those are things that would, you know, potentially get you a flag for either a denial or potentially requests for more information. And then finally, those, you know, the waiver safety explanation guideline questions, answering those thoroughly is a pretty good path to assure success in request. All right, so now we're going to go through a couple of use cases for operations that we've done at Census. So last, I guess it was November or so, we went through this operation where we flew our Centero aircraft along a canal in South Florida. And we were operating under our shielded approval, so we were running this without visual observers, and we ran it along this canal. And the aircraft was the, you know, the reliable aircraft was part of what made this operation viable. But really the biggest thing, and this was for us, this was a watershed moment, was the reliance on the L-site halo. So the L-site halo gave us the C2 link assurance that we had frankly never experienced being able to do this operation. So in this case, the aircraft was flown 15 miles out from the launch and recovery location in the west in this particular image here, and then flown south and then over to the east and then back. And in addition to that, we used our mobile command center that we used as the way for us to make sure that we had, you know, that was the hosting of our ground control station, where we were able to do kind of our operational preparations and to put together this successful operation. But at this point, I really kind of want to, you know, turn this over to L-site and really have Nimrod to kind of give you some more backgrounds on why this system works so well, and it is really a game changer for long range BVLOS operations. Go ahead, Nimrod.
Thank you. Thank you, Rob. Thank you for your kind words and introduction, and of course to the Team Senses for the ongoing support and collaboration. When talking about, maybe let's take a few steps back. When talking about the evolution of BVLOS operations and BVLOS guidelines for regulation, we see across the board, and not only the FAA, but the regulators care at the end of the day mainly about safety and safe operations. And there are different type of measures to tackle this challenge, rather if it's remote AD, safety parachute, detect and avoid, UTM, redundant on a single point of failure. And of course, humbly enough, I think that the most critical is to have a reliable C2 and reliable connectivity throughout the flight. And this is what I will be focusing today. I would like to take the opportunity in the next few minutes to tell a little bit about our experience at Elsight as an enabler for the industry and how we approach the safety challenge. Not in many ways, not only how we try to solve this challenge, but how we pave the path towards BVLOS operations, both over heavy populated areas and rural in the States and globally. Maybe a word about the company. Elsight started in 2009 in connectivity since day one. From 2018, we decided to focus on the unmanned in general, drones in specific, providing what we call absolute connection confidence, where in 2020, we launched our Halo device, which is this, which you can see on the slide, aiming to be the standout solution for reliable C2 for BVLOS operations. Today, in really high numbers, integrated in more than 40 different aerial platforms, performed more than 250 BVLOS flight hours, vast majority of which under the FAA in the USA. Already type certified with one of our partners also from last September in the US. And working a lot of use cases from civilian mapping, delivery, both civilian and military airspace. Again, providing what we call this extremely reliable connectivity, meaning from the service provider drone operator perspective, regardless if you're doing any type of mission, you need to focus on the mission itself, and you don't need to worry if we have reliable C2, if you have video feed, and so on. From the regulator perspective, in the same time, we provide the redundancy or the safety needed to allow those BVLOS operations. How we do it? So we have this edge that normally has these 4 LTE modules. So you can think of it as Verizon, AT&T, T-Mobile, US Cellular. By the way, this is pluggable. So you can take this out and put a 5G module here, or 2 5Gs and 2 LTEs. But even if I take all of them apart, it will still be the same device. Why? Because the Halo, it's not necessarily a cellular solution, but the idea is that through the different interfaces, you can easily connect additional links like your existing RF point-to-point, satellite, or both to create one holistic, robust connectivity layer that leverages all available technologies and typologies without being a failover solution. What do I mean? If we look at what are the technologies today in the industry for connectivity, so you have on the low end RF point-to-point that has amazing latency and performance, but has the limitations of line of sight. On the high end, you have satellite that has always on connectivity as long as you have orbit, but of course, very poor bandwidth and latency, very costly and heavy. And in between, you have cellular, 3G, LTE, 5G. When talking about what are the solutions in the industry today, so you have either companies that are doing one of which, or more sophisticated solutions that are doing RF point-to-point with single SIM, dual SIM, or single SIM with satellite. But they all talk in the same terminology of a primary link and a secondary link, meaning throughout the flight operation, you will go on the primary, let's say your RF point-to-point, and only once you lose line of sight, then the secondary link, in this case the cellular, will kick in while keep on scanning for the primary link again and again, and in between you have this downtime and connectivity. Think of you now just flying to Europe, you just landed, take off your airplane mode, takes you about 30 seconds to get cellular signal on your iPhone. On the application level, because the flight computer may reboot itself, it can take even up to 2 minutes. In our terminology, and this is maybe the biggest game changer, is we say, or that even 1 second of disconnection is game over. So what the Halo essentially does is it maintains an active-active approach of leveraging all available links alive simultaneously. So once the Halo detects degradation or congestion of one of the links, we automatically press harder on the gas pedal on the alternative links to maintain the needed bandwidth with the lowest latency, of course, to allow the continuity of the mission. Around this, we do a lot of prioritization, just as an example, based on data type, where we determine together with the service provider what will be the critical information. Normally will be C2 and telemetry that requires very small throughput. And this we will send 100% redundancy through each and every link, and the package that arrives the first will be the one presented on the dashboard. Alternatively, video that requires more bandwidth, we will split it into packets, send it, of course, everything encrypted AES-256 to our cloud server that can be either AWS-based when talking about civilian, or on-premises we're talking about defense applications, where everything is being deduplicated, resequenced, and sent to your VPN client, either if it's a drone in a box to the GCS or to the office, to the HQ, where the BVLOS operation is being operating from. This is the core connectivity value that we provide. Around this, and this may be more relevant for the regulatory path, over the past 2.5 years, we released a lot of complementary services, what we call BVLOS kit capabilities, that came both from the different regulators and from the industry, to provide, again, a more complete solution for BVLOS C2. So I will mention the one that I think that are relevant. You see them also here on my slide. So first is we have the built-in remote ID, both over Bluetooth for broadcast up in the air, and also for the standard remote ID via the network to the UTM. So if we're talking about the broadcast already certified Part 89 of the FAA, and also the network comply with all the needed standards, as well as any other regulator, either in Europe, in Canada, in South America, and other regions. Second is that to be like a one-stop shop for connectivity, we also provide the SIM cards and data packages themselves. So you don't need to go to the local vendors and try and get prepaid industrial IoT SIM cards, which is, as you all know, extremely challenging. But we provide a complete solution, both with the SIM cards and also very, very soon with the Iridium 9603 satellite module for Keep Alive messages. So again, to be more robust in this way. Another key feature that the FAA in specific requested and show a lot of enthusiasm around is our ability to do RF recording, meaning throughout the flight operation, we are able to detect the signal level of the different telco carriers, and not only upload it live to the cloud and show it on your dashboard, but also the ability for you to create this site survey on planning your routes and your operation zones where you have maximum connectivity signal, but also the ability to share all this information with the regulator to show them how safe is safe enough, where to determine no flight zones because there is no connectivity whatsoever in the region. And on top of this, also show where you are operating and in the same time say that there are no interferences with the terrestrial users, something that concerns the FAA on how to create simultaneously dimensions working everyone without interfering one of the other. With this, I'm okay. So if we're talking about, what our job at Elsight for the industry is, at the end of the day, as Rob mentioned, the waiver and type certification, these are long processes that takes a lot of patience, effort, money, time, and we see us as an enabler to maybe take one less headache from your day-to-day tasks to get these approvals, as the FAA is very familiar with our offering and is very keen to see more and more companies and partners use the Elsight for BVLOS operations. So these are an examples of several markets where we targeted. Few interesting things that we are doing today. So when we talk about logistics and delivery, we're taking part of the Walmart drone deliveries via DroneUp, where we operate in 6 different states, performing many deliveries on a daily basis. Over there, it was extremely important to show the RF stats, what I mentioned before, to get the needed corridors. Other use cases is what we did with Sprite around medical delivery. Sprite in general, their vision was to take different types of platforms, use it for different applications and use cases, and with the ability of the Halo to be like the heart of the architecture on each and every drone. Doesn't matter if it do short range inspection or BVLOS medical delivery. And from this experience, we learned how to make, let's say, one configuration that can easily modify and change according to the different platforms. I will be more than happy to hear any questions that you might have. And of course, take it if needed offline.
Yeah, Nimrod, and thank you for that segment there. And we actually do have a couple questions for you right off the rip here. So the first one we have is, does Elsight Halo provide switching of RF to LTE based on the best signal in conjunction with like a SkyNode X-Flight computer, for example?
So as I mentioned, the approach is slightly different. We do sniff for the best signal level all the time and optimizing the usage of the links, but it's not this link or that link, but we are using all of them together. So once the Halo detects this degradation, so it maximizes the bandwidth by different, we call it the sixth sense algorithm, but the idea is to try the understand the pipe and the quality of service, how much data can we stream, and by this do this flexibility or mitigation in terms of keeping the needed latency first and foremost, and the bandwidth to stream the video, C2 and telemetry. Just to make sure, sorry, we do not provide the RF link itself or the satellite, but we manage it and look it as an internal link. So once the RF, and it can be Persistent Systems, Silvus, Microheart, Doodle Labs, Magic, DTC, any RF link that you will provide, once it's connected and it's basically plug and play, the Halo sees it as an additional links, and then according to your mission, we determine how to stream the data. It can be either 100% in parallel or look at it as a fifth link. There are many different configurations for different applications.
Thank you for that. And I think we have another follow-up question for you on the Elsight. I saw there was a couple of regs questions. So Rob, we'll be jumping over to you here in a second. But is the Elsight on band 14 as well?
Yes, of course. So the Halo is certified in the US, not only FCC and PTCLB on the cellular, but already also certified with all US carriers, including Verizon ALO, airborne LTE operations. The modules themselves, they are Telit, and they support also band 14 FirstNet. We do not provide the SIM card itself, but of course we support it. Moreover, we are able to disable certain bands. So for example, in the US, for civilian applications, the FAA doesn't want us to use band 5, so you can easily eliminate the possibility or disable this band from the GUI on your dashboard.
All right, thank you for that. I'm going to go ahead and hop over to Rob for some questions. But Nimrod, if you don't mind staying on in case someone else drops something in the chat.
Sure.
Rob, I think you might have dropped a link to it here, but Lee asked if you could cite some high altitude waivers and had a follow-up question if there's been one granted for more than 300 pounds.
Sure. So for the high altitude waivers, well, I'm not sure if I can actually disclose who it is, but you can actually go to the FAA's website, and if you look up, if you type into the Part 107 waivers granted, Part 107 waivers granted will basically, it has a list of all the waivers that have been granted by the FAA that are currently active. And if you type in 10751 and then you do the you parentheses B for that, which is B is the part of the rule that is a request for above 400 feet. So that's the altitude exception. That you will come up with a number of waivers. Most of them are just standalone waivers for high altitude, and there's quite a few of them actually. And then as you go through the list and you see, you know, what the way the FAA website is organized is it'll actually show you the 10751Bs, and then it'll also list if there are any other rules that are requested for relief. So if you encounter waivers that say 10731, 33, 51B, those are the ones that are high altitude BVLOS. So all the other ones are just simply high altitude that are within visual line of sight. Regarding heavier aircraft, so none of those are covered under Part 107. So there are a number of organizations that are operating heavier aircraft in the U.S. I don't know specifically about 300 pounds, but there are companies that are operating aircraft that are, you know, closer to the weight of an actual aircraft. So you have some of the eVTOL companies are operating their aircraft under special airworthiness certificates, where they'll be running them either unmanned or with a safety pilot in the aircraft. You know, for the UAS specific, there are companies that have filed for exemptions where they are running either with a special airworthiness certificate for those aircraft that are above 55 pounds that they're using in commercial applications. A couple that I can think of offhand is Phoenix Air Unmanned was one of the 4 organizations that got the exemptions that were released last year, where they're operating a Swiss drones well, it's a helicopter with 2 main rotors, and that aircraft weighs just under 200 pounds, and they have an exemption to do shielded operations for linear infrastructure inspection work, which is part of what Phoenix Air does. Is kind of their regular business as a drone service provider. And then more recently, there's been an approval for I believe it's Chevron working with American Aerospace where they've been granted an approval to operate their aircraft up to 1,500 feet, leveraging onboard DAA in the form of radar panels. So.
Thank you for that, Rob. And can you kind of tell us, Lee, also had a follow-up question, who issued the Part 107 waiver safety explanation guidelines and guiding questions?
Who issued it's the FAA that issues those waiver safety explanation guidelines.
Okay. All right. Thank you for that. I'm going to jump over to Nimrod. I have a question for you real quick. How much power does the L site need an hour to operate?
First question. So in terms of the heat index and power consumption is relatively low. We're talking about the input, we're taking in between 9 to 30 watts, and we're using 6 watts.
Awesome. Thank you. Bill, if you need more clarification on that, please type us in the chat there. And then back over, I think you got exactly what Bill's looking for. Yeah, he said thank you. Jumping back over to you here, Rob. Can you speak to ODOT's waiver with BVLOS and Flight Over People as like to the safety risk and mitigations? Oh, we're muted there, Rob.
There we go. All right. Sorry about that. Yeah, so the Ohio Department of Transportation was granted an approval earlier this year under Part 107 where they're operating a Centero it's part of their smart corridor that they're doing in Ohio. And what they're doing is they're using the Centero to do operations to do offset from one of the roadways to do an inspection operation. And as part of that, they've got a small section of that corridor that's allowed for them to do operations over people and moving vehicles. And so what they were able to do, how they were able to get that approval is they were able to cite the history of our aircraft and our airframe showing its reliability, that it is, even though it doesn't meet the operations over people rule requirements, nor is it equipped with a parachute, it is, there's enough operational history to show that for low risk operations that it is acceptable to fly the aircraft over people and moving vehicles. So again, the restrictions are, they fly over in that operation in Ohio, they're flying over a couple of roads. So it's a pretty low likelihood that they're going to be flying over cars that are traveling down those secondary roads.
Thank you, Rob. Scott said thanks and great seeing you. So I
Yeah,
just
good to see you too, Scott.
transmit that one for you. I know I keep jumping back and forth here, but Nimrod, we got another follow-up question for you from Blake. Does Elsight have any plans to add capability with DJI enterprise drones like the M300?
Great question. So really in the upcoming weeks, I don't want to commit on when, but in no time from now, we will declare a new offering for the M30 and T30 and M350 on an end-to-end plug-and-play solution to provide LTE, which is, let's call it Western LTE of the Halo as an add-on on the DJI. For the bigger versions, you can already use the Halo for the Matrice, the RTK 300. We're using the DJI manifold, of course, for which you need third-party flight operation system. But soon enough for the M30, we will have something that hopefully will be a key message, let's say, to the industry and specifically to the band of DJI in the US.
Well, it looks like you might have made Blake stay here with that answer, so he's excited for that. Thank you, Blake. We're really excited for this webinar, and we're excited to do this on a biannual basis. Regulation is changing so much that having updates every 6 months is probably not even enough. But we're excited to have another one, so make sure you keep on the lookout for that. We do have a time for a few more questions, so if anyone has a question, feel free to drop it in the chat. I'm going to go ahead and throw a question here at Rob. So, we didn't really touch about this at all, but detect and avoid systems. You want to touch on that a little bit, Rob?
That's detect and avoid is it's a big topic. I mean, it's a big part of the picture when it comes to BVLOS operations. So one of the things, right now the FAA is in the process of developing a new rule for BVLOS operations. And part of that rule is going to get into a whole bunch of different things. So it's going to go everything from training to operator certification. So operator permitting basically. So, the premise would be under a rule that there's going to be more corporate responsibility for BVLOS operations that are conducted to maybe take some of the onus off of individual responsible persons and RPICs. I don't know what that looks like yet. It's still, in work in process. But part of it is, questions about detect and avoid. And so what has happened in recent years is there's been a lot of work on detect and avoid standards. And so, we're involved with the ASTM working group for the detect and avoid test methods. So there's a standard that was released recently on detect and avoid performance standards for the types of aircraft that are typically being used by our clients and most people that are doing commercial operations under Part 107. So these lighter, smaller RPAS are somewhat limited in what they can actually carry for size, weight, and power for detect and avoid. So that's why it's a challenge. So before the ASTM standard was released, the other standard that existed was the RTCA standard, which was set up primarily to address detect and avoid requirements for any aircraft. So basically, RPAS or crewed aircraft alike, but it was envisioned for RPAS that are operating within more common altitudes that crewed aircraft are typically operating now. So the distinction there is that if you're flying an aircraft, an unmanned aircraft at 10,000 feet, there's a chance that you could encounter a jet that it has a cruise of speed of 400 knots. Whereas if you're operating at 400 feet or lower, the likelihood of you encountering something going that fast is slim to none unless you're in the approach path of an airfield. So the ASTM standard is a bit more right-sized in the detection distances that are required for detect and avoid, and I realize this is a big topic so we Census, we have a detect and avoid sensor integrated into our aircraft, which is the Casio One. So it is a forward-facing sensor that is part of our air risk mitigation strategy that we are getting some credit for, but certainly it's not giving us the flexibility to do kind of carte blanche BVLOS anywhere we want to, without a lot of extra contingencies in place. So that's as an organization, we're continuing to look at different options as DAA tech continues to evolve and mature, to basically help to unlock even lower restrictive operations for BVLOS.
All right, thank you there, Rob. We got another question for Elsight from Pablo. Does Elsight perform any BVLOS flight testing in Europe? And if so, do you have any feedback from European authorities so far?
Yes, of course. So today we have in Europe over 20 key partners, service providers, and drone manufacturers, both in the UK with CAA, and also for different SORA approvals across the EU. Just for you to understand in numbers, we have a Polish partner who made enough mileage in BVLOS operations to orbit the Earth twice, and this was he declared like a year ago. So if I'm not mistaken, in between 6 to 8 companies already got SORA approvals based on the Halo. So definitely a lot of experience. At the end of the day, one of our challenges is that we are not in the front with the regulators. So in many cases, we do get the, let's say, compliance table and help submit all the paperwork, and we have documents around it to facilitate the process. But it's not that I'm going in the front and opening the doors and helping with the approvals themselves, but staying in the back to do as best as we can.
Thank you for that. And throwing it back to Rob here. And thank you, everyone, for the questions. They've been great so far. Blake had another follow-up here for you, Rob. Has Census had any BVLOS or EVLOS approvals for controlled airspace, or are they approvals primarily for Class G?
So we have had approvals for running operations in controlled airspace, and in fact, an airfield where we do a lot of our checkout testing is in controlled airspace. It's a Class Delta, in Ormond Beach, where we were able to do BVLOS operations, both EVLOS and BVLOS, so with visual observers and also leveraging low altitude shielding. So that is part of our safety case where, the performance-based requirements that we've put forward allow us to do operations in any controlled airspace. The restrictions become the proximity to the airfield. So, the way it's set up is if you're closer than 3 miles, you need to do some coordination with the airfield that you're operating near. So if it's an airport and it is a controlled airport, you have to apply for an airspace authorization through the drone zone because you can't actually use LANCE for an approval where you're using it with an operational waiver. So, so when you apply for your approval for the drone zone, you would actually have that opportunity to do that coordination with the air traffic facility that is where you're looking to conduct a BVLOS operation. So yeah, we have done it and it's worked out pretty well. So
Thank you for that, Rob.
bet,
And I don't see any more questions lined up here. So Rob, if you want to just run through this quick operation. So we actually ran with the storm that was heading towards Florida this past week. We actually ran an operation using the Sotero system again, combined with the L site for a BVLOS operation. So Rob, can you kind of just run through this real quick and just before we close out here?
Yeah, sure. So this was an operation that was conducted last Thursday, as it turns out. I was in Baltimore actually reviewing the plan for this. Well, I'll give you a little backstory here. So as part of our waiver operations, we have the remote pilot, in this case, it's Patrick, who's you've seen here on the screen, goes through the flight preparations and sets up the evaluation of the location based on the criteria that's laid out in the waiver that we've been granted. And as part of that process, there's a baked-in review process. So Patrick is required to review the waiver or not the waiver, the operation with me before, to ensure that, everything that he's identified as being in compliance with the waiver is in fact in compliance. And so basically my role in that case is I'm providing the sanity check on the operation to verify that there aren't things that he may have overlooked in his evaluation of the area for the suitability for doing the BVLOS operation. So in this case, we were able to get out there and run this operation along an 8-mile section of the shore there in Flagler. We did have to use visual observers in this operation because we're on a beach, and really we used a lot more visual observers than we typically would have because of the fact that there were discrete areas along the beach where the ground risk was higher. And so we had to make sure that we had visual observers reporting back to the RPIC, when to pause the progression of the mission to kind of make sure that the ground was clear, so that we weren't providing like an undue risk to the people on the ground below. So yeah, and the operation worked out pretty well. And again, this was one of these operations where, it took us like 6 to 8 hours of planning and review to actually prepare for this flight that ended up taking maybe 40 minutes. So it was relatively quick operation once it was executed, and it actually provided the folks at Flagler County a lot of great information ahead of the storm that rolled through this past weekend. Or they still actually, I think the rains are still coming down in parts of Georgia and coming in the Carolinas now. So.
All right. Well, thank you for that, Rob. And I don't see any more questions in here. I want to thank everyone again for joining us on this webinar today, and keep an eye out as we hope to have another one in about 6 months with some new information updates on new waivers getting approved, new updates from LSite. So we're really excited to continue this. If you have any questions, feel free to email me, Rob, or Nimrod. We'd love to connect with you. And once again, thank you all for joining, and have a great rest of your day. The recording should be sent out in the following hour or so once it's done processing. So keep an eye out for that.
Hey, Adam, I want to interject just one more thing here. So, one thing that just to kind of go back a little bit here, there was it's only been in the past 3 or 4 years that civil aviation authorities have actually accepted the use of LTE as a communications method. And so that is a huge shift, so we can all of us can thank, I believe it was Qualcomm that did a study back in the 2016 timeframe where they basically, were first putting modems on drones and verifying the connectivity at these lower altitudes that we particularly, the 400-foot mark that is typically allowed under Part 107. So that's really kind of the basis about how we got here. So if those studies hadn't been conducted and the FAA hadn't accepted the fact that this is a viable, robust communications method, we wouldn't be having this conversation right now. And this operation on Flagler was done as a result of having that connectivity that was provided by the L-site system. So it's just something to keep in mind. So it's an exciting time. I'm really excited to see that we're actually getting to this place where we have this type of C2 options in place that are giving that assurance that is required for all of us to make sure that the aircraft is fundamentally safe and that the regulators are satisfies their requirements as well. So it's good times.
Well, thank you very much. And sorry if I cut you off there, but Nimrod, do you have any closing remarks you would like to add as well?
Well, I think Rob said it best. Someone asked before, what is the biggest BVLOS challenge? So I would say, get the FAA to approve of or get of something, create a standard, any standard, and let the industry live up to that standard. We are in good place, but we are still, learning on this learning curve and doing our best to facilitate and make the industry move faster. And we'll keep continuing it. We will be in Vegas, by the way, in 3 weeks from now. So hopefully we'll see you all there.
Yes, and all those traveling to Vegas, have a safe trip, and we'll connect with you then. Until then, everyone have a good one and a good rest of your week.
Thank you very much.
All right. Thanks, everybody.